In this module, we'll demonstrate how non-ephemeral self-hosted runner can be vulnerable, provide an example of a misconfigured workflow, and walk through an exploitation scenario where an attacker leverages these vulnerabilities. Lastly, we'll cover the best practices to secure runners and mitigate these risks. First, let's differentiate between non-ephemeral and ephemeral runner. Non-ephemeral runners. These runners are persistent between jobs and workflow runs, retaining their state. While these can be convenient, it introduces a risk of runner persistence by attackers, allowing them to maintain access over time since the file system where the workflow run isn't deleted after each run. Ephemeral runners. These runners are short lived. They are spun up for each workflow run and destroyed afterwards. This reduces the attack surface as each workflow starts with a fresh environment, making persistence across runs impossible. Non ephemeral runners are the default way of spinning up self hosted runners in GitHub Actions. A vulnerable runner would contain the following configuration. First, it would be running in a public repositories workflow, and it would be running on a self-hosted runner which is non-ephemeral. This can easily be identified by looking at a recent workflow run, and during the checkout step it would contain a step called cleaning the repository. If cleaning the repository step is present, then it means it is a non-ephemeral runner. We'll look at the exploitation scenario now. So in this scenario, an attacker first makes himself a contributor by submitting a legitimate pull request to fix any of the issues. Once an attacker obtains the contributor role, an attacker could then submit a pull request that includes a malicious workflow which would run on the self hosted runner. If the runner is misconfigured, this code can run with runner's permissions, potentially compromising the system. An attacker would first maybe fix a typo and make a PR. The developer would approve and merge the changes to their repository. Once this is done, an attacker would obtain a contributor role. Once an attacker has this contributor role, they can register the self-hosted runner that runs workflows of vulnerable repository to run the workflows from their C2 repository directly, which just means that they'll be attaching the self hosted runner to their repository and execute commands directly on it. To do so, an attacker would first obtain a runner token for his C2 repository and use this token on the malicious workflow so that the workflow, when run, registers the self hosted runner to the C2 repository. This can be done by creating a PR with the said malicious workflow file, and when a PR is made, the workflow would run and register the self hosted runner to the C2 repository. Once the self hosted runner is registered on C2 repository, an attacker could directly specify the self hosted runner in his work or her workflow and have it running the malicious commands that he or she wants to run. Which would essentially mean that an attacker would obtain remote code execution at this point of time, and the repository would act as a C2 repository. We'll now look at the exploitation steps. The first step of this would be to become a contributor on the vulnerable repository. This can be done by first forking the repository. We could then make some changes to readme file here. Once we make a legitimate change, we can make a PR. Once reviewed, the developer of the specific repository or the maintainers would merge this pull request. Note the first time contributed label attached to our attacker user initially. Once this PR gets merged, this would be just contributor, as it can be seen here. Once we've gained this contributor role, we can then proceed with our malicious workflows. Before we start with the exploitation, we'll create a repository called C2 repository. We'll first need to create a runner token. This can be done by visiting settings and going over to runners tab and clicking on new self-hosted runner. This would be the token to register a self-hosted runner for this repository. We'll make a note of this token now. Once we've obtained the runner token, we'll use the malicious workflow from the lab guide here. We will replace the runner token variable with the token we've obtained before and replace the repository here with the C2 repository created here. We will commit the changes and later make a pull request. We can see a malicious workflow being executed here. Once we've run the malicious workflow from the lab guide, we should be seeing something like this. What this essentially does is register the self-hosted runner with our C2 repository with the runner token. We can confirm this by heading over to C2 repository and runners. We will find the runner here. We will now create a workflow under C2 repository and run commands on the self-hosted runner that was just compromised. We can again use the workflow from lab guide to run commands on the self-hosted runner. The code here will print out any .sh files under the temp directory. This is the directory where any of the workflow that will be run would be stored as a bash script. So before we run this command, we will need to simulate a workflow run that would have secrets in it. Here we can see secrets.flag as one of the steps. Now we'll run our workflow. As it can be seen here, we've successfully extracted the secret value, which is flag value here, and the workflow that was running is the one here, where we echo the value of secrets.flag and sleep for 60 seconds. And this is exactly what we can find here. We'll look at the payload again and try to understand what the malicious workflow does. So the workflow first tries to download the self-hosted actions, extracts it, and configures it with the token that we've um, taken from the C2 repository. It then exports environment variable called runner tracking ID to 0, so that GitHub doesn't terminate our process after the action is run, and no hop here to run our self-hosted runner in the background. And the workflow under our C2 repository tries to extract the bash files under this specific directory and prints out the bash files to get the secrets associated with each of the step. To secure workflows using self-hosted runner, we'll follow the best practices like avoiding the use of self-hosted runners on public repositories, using ephemeral runners that automatically clean up after each run, we can minimize the permissions for the workflows running, and use GitHub's built-in security features that prevent any external contributors from running workflows before it's reviewed. By understanding the vulnerabilities associated with non-ephemeral self-hosted runners and implementing the recommended best practices, you can improve the security of your CI/CD pipelines and protect workflows from potential exploits.